Good afternoon, everyone. My name is Nika Durham from the National Renewable Energy Lab, and I'd like to welcome you to today's webinar on the Energy Systems Integration Facility's Annual Call for User Access. We're excited to have you with us today. We'll give folks a few more minutes to call in and log on, so while we wait, I'll go over some logistics and then we can get going with today's webinar. I want to mention that this webinar will be recorded and everyone today is in listen-only mode. You have two options for how you can hear today's webinar. In the upper right corner of your screen, there's a red arrow. If you click on it, it opens the webinar toolbox and there's a tab that says audio. This will allow you to choose whether or not you want to listen to the webinar through your computer, speakers, or a phone. We'll have a question and answer session at the end of the presentation. You can participate by submitting your questions electronically during the webinar. Please do this by going to the questions pane in the box showing on your screen. You can open it to type in your questions that you have during the course of the webinar. Our speakers will address as many questions as time allows after the presentation. Before we get started, I'd like to introduce you to our panelists today. With us we have Sarah Truitt, NREL's ESIF User Program Manager, and Greg Martin, ESIF Research Engineering Manager. We also have Andrew Hudgens, User Program Integrator, in the room to answer questions. With that, I'll hand it off to Sarah to start today's presentation.
Thanks, Nika, and welcome everybody on the phone. The objectives today for this webinar are to provide an overview of the current opportunity to work with NREL in the Energy Systems Integration Facility, or the ESIF. We will review the details for submitting a proposal, and then we will talk about the technical capabilities and show you some project examples and how others have used these capabilities in their research. And as Nika mentioned, we will have time after the presentation for questions and answers from participants. So the National Renewable Energy Lab, or NREL, is one of 17 national laboratories in the Department of Energy complex. NREL is unique because we are the only lab stewarded by the Office of Energy Efficiency and Renewable Energy within the U.S. Department of Energy, and we have a single-purpose mission here at the lab, and that is to work on clean and sustainable energy. So NREL employs almost 2,000 staff on our main campus, and our mission is to advance the science and engineering of energy efficiency, sustainable transportation, and renewable power technologies, and to provide the knowledge to integrate and optimize these energy systems. So today we'll focus on the ESIF, which you see here on the right side of the slide. ESIF is designed to address the challenges of our changing energy paradigm. So we are moving into a world where we will have millions of distributed devices. We have two-way power flows. We're more digital, more connected, and areas that once operated in silos are now starting to come together, like our transportation systems, our built environment, and our power grid. So ESIF is a critical resource in this energy systems research and development ecosystem, and it is the nation's only user facility equipped to support research aimed at optimizing our entire energy system at full power. So this is a federally funded facility with state-of-the-art capabilities that no one company would typically build on their own. And as a user facility, the external research community is welcome and encouraged to come and conduct mission-aligned research here in this facility. So to address this changing paradigm in our energy ecosystem, research in the ESIF is focused in 6 major areas. Energy security, focused on distributed energy resources and all of the connectivity that is increasing on our power system. System resilience, to build resilience into the grid as we connect many, many more devices than we have traditionally on the power grid. Grid systems integration, that is looking at how you manage and optimize all these devices on the grid. Building and thermal technologies, where we're looking at a whole new paradigms of behind-the-meter grid solutions where buildings actually interact with the power grid. Advanced mobility, looking at electrification as well as fuel cell vehicles. And renewable fuels, gas, and energy science, where we do quite a bit of hydrogen, fuel cells, and battery R&D. So today we'll provide an overview of the capabilities you can use for this type of research and look at a few projects that have been successful. But first I'll review the user call and the details for submitting an application. So the ESIF user call is a process by which potential laboratory users and partners request use of the facility for the upcoming fiscal year. A majority of our laboratory resources are allocated on this annual cycle. However, additional projects can come in throughout the year if we have the resources available. We'll try to accommodate them. So this year we have 3 topics: energy systems integration, materials or device development, and high impact projects. And the objective is to make the unique capabilities of the ESIF available to the research community to help accelerate the shared mission of your organization and ours. So here is a snapshot of the schedule. This will be displayed on the last slide as well. So when we get to Q&A, we'll stick on the schedule slide. So we issue the solicitation July 15th. The last day for submitting questions is August 23rd. You would submit a question to userprogram.esif@nrel.gov, that email address that's shown on the bottom of the screen. Proposals are due August 30th at 11:59 p.m. Mountain Time. Review and selection will take place for topics 1 and 2 between September and November 2019, and for topic 3 between November and December 2019. And that's our anticipated schedule. Once selections are made, then we need to negotiate agreements, and the estimated time frame for that is December and January, although it does really depend on each project. And the period of performance is up to 12 months with an option to extend the next fiscal year, pending review and application. So the solicitation has a lot more details, and that is a Word document that is available on FedBizOps, and that link there is down on the bottom as well. So for-profit, nonprofits are eligible: state, local, tribal governments, other government laboratories, non-DOE federal agencies, and consortia are eligible. You can be a domestic entity or a foreign entity, but please note all foreign entities and foreign funding sources would need to be approved by DOE before they're granted access to the facility. Individuals are not eligible to apply for this opportunity. So ESIF Operations has an entire staff of engineers and technicians that will ensure the proper training and oversight, setup, and decommission of your experiments in our facilities. NREL may also produce some publicity items such as a fact sheet, a poster, a presentation, or include the results in a publication to share about your project. But there's no funding associated with this opportunity for applicants. Applicants who want to use this facility must have funding for their researcher. You may use an NREL or request an NREL staff member to conduct the research on your behalf, or provide your own qualified researcher. It's also important to note that we accept both proprietary and non-proprietary work in the ESIF. The proprietary work requires that as a user facility, we recover our costs, and there is a fee associated with the duration and amount of your use that we charge for proprietary work. So all agreements and all projects in ESIF must be governed by an agreement. So the DOE gives us quite a bit of flexibility with various types of contracting vehicles we can use. And it is dependent upon the scope of work and what is negotiated through NREL's Technology Transfer Office, which agreement is deemed most appropriate. There's a list of agreements here at this link to NREL's website where you can read through some of those details. And please, if you have questions, email that userprogram.esif@nrel.gov, and we will post the answers to your questions. Okay, we're moving on to the proposal package. So to apply for access to ESIF, you will need a title page, a 5-page body, your resumes, and a summary slide deck. The summary slide deck template varies depending on which topic you are applying for, and the templates are available at FedBizOps or on the ESIF Working With Us website. It's important in your project to describe what you need in the ESIF as well as where your funding will come from. And please do email your proposal package to userprogram.esif@nrel.gov by the deadline on August 30th. So each proposal will be reviewed for mission alignment, research impact, and ESIF stewardship and strategy. Reviewers will assign a score to each area, 1 through 5. So a low score of 1 would be assigned to a project that is not specifically aligned with our mission or doesn't specify that it's aligned with our mission. A high score would be given to those applicants that specify specific goals that they align with. Research impact is based on the level of interest and applicability to the broader research community as well as the market and industry writ large. A project would score low in this area if it was of interest to a very narrow sector of the economy or research area, and high if it has wider applications. And I will walk through some projects at the end of this presentation and point out which ones would score well in these different areas. ESIF stewardship and strategy is based on whether the project uses a unique capability within ESIF. So as our demand is increasing, it's increasingly important for us to ensure that the project really must be done here using our unique capabilities. And whether the project is likely to bring in long-term partners who will do continued research with NREL. So the topic areas, we have our topic 1, energy systems integration, and topic 2, materials or device development. So keep in mind that the key research areas on the left are the areas of research where we'd like the proposals in, and then you would choose your topic based on where your proposal best fits. So energy systems integration projects could focus exclusively on grid modernization challenges, or it could focus on addressing the interdependencies between 2 or more energy systems. These are both acceptable under topic 1. Topic 2 includes development or characterization of new materials or processes that advance a specific device or component. And topic 3 is high impact projects. High impact projects have a bit of a higher bar to meet because in addition to being aligned and impactful and utilizing ESIF in the right way, they also need to meet these 5 criteria. They must involve multiple technologies of interest to the Department of Energy's Energy Efficiency and Renewable Energy Office, such as solar, wind, geothermal, transportation, buildings. They also must address challenges outlined in the DOE Grid Modernization Multi-Year Program Plan, and there's a link provided here to that document. They have to demonstrate impact on the companies and the regions that it supports. It must be nationally scalable and result in lessons learned that could be implemented nationwide. Further details on the specific goals can be at that link shown above. You may also learn a bit more about grid modernization and our projects in what we term new mission space in the ESIF stewardship plan. There's a link there, and both of those areas are described in the stewardship plan online. So at this point, I'm going to hand this over to Greg Martin, our research engineering manager, to run through some of the capabilities we have in the ESIF. Unless anybody has any questions at this point. We'll keep moving and put questions at the end.
Okay, thank you, Sarah. My name is Greg Martin. I manage a group of engineers here at the laboratory, and we administer these capabilities and support the projects in conjunction with a wider operations center to kind of implement these things from a safety, high quality, and efficient standpoint. So it's myself in conjunction with our operations manager, Joe Shakiro, are kind of the let's execute these projects that we bring in the door. So this graphic is a layout kind of our facility. We've identified 3 main zones, and these are not exactly like big walls between them and can't change. There's a little fluidity in this, but these spaces are roughly dedicated to different kind of mission areas at ESIF. The purple is the zone or the laboratory spaces and areas that we are targeting for this user call, as well as the green areas. And the purple is the kind of more electrical integration space that also involves thermal and fuels. But we have also a lot of kind of analytical chemistry laboratories and hydrogen integration apparatus and systems near the rear of the facility that also is targeted by this user call. We are not going, there is a separate user call that the high performance computing and data center has. So this particular call is not part of that. So there would be a separate user call if you want to use the computing resources in the Eagle supercomputer at ESIF. We will go into a little bit more detail on these zones, so if you go to the next slide, Nika. So in the electrical integration area, we have, overall in ESIF, we have kind of 4 main energy systems that we're looking to integrate. And integration happens both within these energy systems and across these energy systems. These are electrical, thermal, fuels, and then data, communications, and control. And data, communications, and control are not really an energy path, but that's a key enabling, layer that is required to enable advancement in these energy areas. Pictured on this slide in the center is a little bit busy diagram, but kind of a representation of how these different systems route throughout the facility. And this is kind of to indicate that we have integrated systems ready to go. So it's not that a specific type of experimentation is tied to a specific laboratory space. The focus is on being able to integrate things together. So we have a lot of flexibility in being able to place different experiments in different places and tie them together. The electrical infrastructure is kind of a key part of this. And I think on the next slide, we have more information on the electrical research infrastructure. So we have an alternating current bus, a direct current bus, and then a medium voltage AC bus. These are research buses. So this is not just facility or campus power from Xcel Energy tied into the facility. These are dedicated research assets that we have full control over, meaning we can turn them off, turn them on, change the voltage, change the frequency, basically do what we need to do to complete the mission in energy systems integration. These buses enable integration across the facility by tying together lots of different laboratories and lots of different key equipment and facilities. Represented on this slide are several of the, key capability areas that we offer as usable or areas to develop or do research in around this electrical power infrastructure. So just to highlight a couple, we do work with microgrids So we have microgrid controller capability that we use to control multiple assets, and we use to do research and development on network and communications methodologies, security. We have electric vehicles that charge from this electric power system. We have buildings and real building components such as appliances that can tie into the buses and act as a controllable part of the system. So in all, we've built up lots and lots of real controllable grid devices that you find in the real world to offer up this test environment, evaluation environment for doing electrical power grid integration work. Some of the notable equipment associated with that previous electrical research infrastructure slide include a large high-power grid simulator asset, large power PV simulator asset, and battery DC simulation. So that would be bidirectional DC simulation. We have a programmable load bank that is capable of resistive, inductive, and capacitive. As I mentioned, there's a medium voltage test environment that offers power conversion and actual flexibility to tie to our grid simulator, so we can do grid simulation at medium voltage and control voltage and frequency, even up to 15,000 volts. We use environmental chambers to subject equipment under test to varying environmental conditions. Again, large inverters, hundreds of real controllable grid devices. We have an outdoor test area called the low voltage outdoor test area. That is our fossil fuels area that we have 3 diesel generators and are working to install natural gas turbines that have CHP. In addition, inside we have carbon exhausts in the floors of most of the large high bay laboratories that allow us to do internal combustion generation work inside. We have a smaller combined heat and power natural gas fired reciprocal engine operating in one of our laboratories. So those are good examples, I guess, of equipment that illustrate energy systems integration spirit, where we're working on combining combined heat and power and thermal with electrical energy management. You'll find various vehicles around the laboratory and vehicle charging capabilities, as well as buildings, both residential and commercial scale. So moving a little bit farther now into the fuels and renewable fuels area, closer to the back of the facility, we operate, I guess, what I would call a pilot hydrogen plant. And I say that because we have the full cycle of hydrogen fuel handling represented at ESIF, and that starts from electrolysis tied to an electrical power source, which could be and is our research electrical distribution system. So our research electrical ties in to an electrolysis capability that produces hydrogen from water. From there, we compress hydrogen into 3 different pressures using 2 large compressors. And we do research with compressors. We also do kind of systems research on processes for safely handling this hydrogen. But the 3 storage pressures we have are roughly 3,000 pounds, 6,000 pounds, and 13,000 pounds. Those they vary in what volumes we store, and we're actually working on adding to those volumes as we speak. That product is then utilized in various ways, notably by hydrogen vehicle fueling dispensers at both medium and high pressure. We do fueling and support a small kind of variable fleet of hydrogen vehicles using the product we produce here. This hydrogen is also utilized by the multiple analytical chemistry or energy science laboratories that live nearby in ESIF. We call it house hydrogen. but we have a piping system that provides hydrogen product to those laboratories to support the research going on there. Just to make sure that nobody's confused, top left photo here is the stacked test bed. So that's something that NREL designed and built, and is a balance of plant system that's enabled and ready to accept large format electrolyzers that are, namely PEM electrolyzers that convert electricity and water into hydrogen and oxygen. There's an image of our dispensing system on the bottom left, and then the graphic in the middle is a slightly dated view of the main storage yard, and we've added to that a impressive capability actually with biomethanation that Sarah is going to address in a subsequent slide here. Notable equipment, I've kind of touched on a lot of these, but for your information, if needed, we've got this documented on the slide: hydrogen storage, generation compression, vehicle dispensing. We have a plant control system that NREL has designed and built and manages, and we have really a spotless track record for safety operating the system over multiple years. It's pretty impressive, the complexity of the system, including all the controls and monitoring, and we've been able to safely do this and conduct a lot of research and development, which is, on top of just handling these pressures and hydrogen flow rates, quite a feat, I believe. So kudos to our hydrogen team on that. The Energy Sciences Laboratories, we support research and development, as Sarah mentioned, primarily for fuel cell and hydrogen system, energy science research. We also do manufacturing techniques and processes. We have some work in lithium-ion battery failure modes and thermal energy systems and sciences, things like phase change materials and energy storage, thermal energy storage materials. And all of those laboratories are supported by various analytical kind of benchtop chemistry types of assets like GCMS and FTIRs, and some of those things are listed here. Next slide. So building off of those equipment and kind of systems capabilities I mentioned, we have some kind of coalesced research and development methodologies that we stand up as critical capability platforms to support the research and development that we are calling for at ESIF. A big part of that, and a kind of an enabling methodology, is called hardware in the loop, or maybe some people have heard of the term power hardware in the loop, or PHIL. This slide kind of brackets the different penetrations, I guess, of real-time simulation into the real hardware testing world. So starting on the top left, of course, this is the modeling system where there's a lot of modeling and real-time simulation that our research groups do here at NREL to understand all kinds of different transmission system, energy system, distribution phenomena, and do analysis and research techno-economic analysis and things like that. From the standpoint of the laboratory, real-time simulation is a key component, and we offer multiple platforms and capabilities for developing and executing real-time simulation. So right now we offer RTDS, which is a brand of real-time simulator. We offer Opal RT, which is another brand of real-time simulator. They have different kind of modeling packages that can be kind of like a personal preference or a institutional preference on which is preferred. We also have a smaller Typhoon system. I'm sorry, not Typhoon, SpeedGo, and we're looking into getting Typhoon if anyone's a RTS aficionado. So top left, full simulation. So that's you've just basically taken some system or some energy system that you care about doing R&D on and simulated it in some physics-based model environment. So the next step is, okay, well, let's add some hardware to that completely software model. So we break out signals at critical parts of that model that would interface with the controller, or that a controller could impact, into real-world analog or digital signals in the laboratory, and actually hook up a controller. And in this case, we're giving the example of a microgrid controller. This essentially functions to trick that microgrid controller into thinking that it's functioning in some kind of real-world simulation. Nothing new there. In this case, we're applying that to grid devices and energy systems integration topics. So that's kind of the twist that ESIF brings to that kind of methodology. And furthermore, number 3, bottom left, we expand that into the power area. So in addition to a real-time simulation interfacing with a real hardware controller, we can bring in power equipment to the quote loop by breaking a part of that real-time simulation signal out into an analog signal and amplifying that to a real voltage, a real-world voltage and power signature using our grid simulators, which are just basically big amplifiers. So now we've got a power system that's operating based on what a real-time model is calculating. That power system then is hooked up to something like a large inverter or a series of smaller controllable grid devices. And we read or sense the response of all of those things connected and transform that back into the simulation model in real time, so that every time you have a simulation calculation loop, we have a real-time update of what the real hardware is doing out there in the laboratory environment. So really, we've hybridized the laboratory, and we're offering this capability to make the laboratory kind of bigger than we could ever build a real hardware, fully hardware test setup, which is what's shown on the bottom right, which is hardware only, that you to understand. Not using any modeled or real-time simulated physics-based simulation platform. You're hooking up and running the real hardware as it's intended to run. Another key testing platform or evaluation platform that we're doing research with is an advanced distribution management system. So distribution management systems are utility control environments that allow utilities to both monitor, understand, predict, and then control distribution systems. What we're doing at ESIF, or what we have done, is we've built a test bed around this concept using and leveraging some of these other capabilities that I've mentioned to allow folks in this technology area have a living, if you will, test bed that basically allows us to trick now an ADMS system into thinking it's working in the real world using both controller hardware in the loop and power hardware in the loop. We can go into more detail on this test bed if people are interested. I'm happy to, but I think right now, in the interest of time, we'll go to the next section with Sarah Truitt to talk about some of the capabilities in action.
All right, thank you, Greg. So in this section, I'll just very briefly touch on each of these projects. These slides will be available so you could read more about them. We have lots of information about them on our website. But what I'll be pointing out is what capability they utilized and the attributes of the project that made it successful or would score well in a proposal. So San Diego Gas and Electric utilizes our power hardware in the loop capabilities that Greg just described to demonstrate the viability of a microgrid to manage very high, up to 100% renewable penetration, while it is meeting the community's load and avoiding adverse grid impacts. So here at the ESIF, we developed advanced testing methods and a test bed that can be configured to utilize electrical signals from SDG&E through a remote hardware in the loop connection. So this is one of our first high impact projects So you can see here it includes multiple technologies: solar, storage, lithium batteries in this case, and ultracapacitors. This has widespread impacts because it's a model for other utilities that are interested in owning and operating microgrid assets. So this would score pretty well on both the high impact project criteria and research impact criteria. The next project is our Eaton Mobility project that is utilizing ESIF controller hardware-in-the-loop capability to develop and validate a framework that optimizes mobility, and in this case it's school buses, with solar and buildings, this case schools, and storage to maximize the value of the entire system. So at ESIF we are working with Eaton's Power Expert Energy Optimizer site controller to analyze bus routes, charge rates, identify optimal battery sizes so that we can begin to understand the value streams of this entire system and how to optimize that. So this is, so the next one is our Holy Cross Energy project. Holy Cross is a co-op located in Colorado, and it is leveraging our Advanced Distribution Management System, or ADMS, testbed to develop and validate new grid visualizations and control paradigms that can lead to new business models for co-op utilities and municipally owned utilities by integrating grid-friendly and intelligent distributed energy assets. The lessons learned from this project are applicable to co-ops across the country, and an important aspect of this project is the partners that we have. So the National Rural Electric Co-op Association, NRECA, is playing a major role in helping to disseminate the lessons learned from this project. This is one of our current high-impact projects. So the next project is Southern California Gas, or SoCal Gas. This is utilizing our hydrogen production and storage system at the ESIF. So through this project, we are developing a novel method for integrating water electrolysis with a biomethanation reactor. So here you'll see pictured our bioreactor. It's a 25-foot tall tower sitting in the backyard at ESIF. And we create renewable natural gas by using renewable energy to run the electrolysis process, and then feeding, there's some bacteria bugs shown, these green little squiggly lines. Those are bacteria. That's the catalyst that actually takes the hydrogen and the carbon dioxide and then produces a renewable methane or renewable natural gas. And there's quite a lot that can be done with renewable natural gas. In this particular project, the idea is that curtailed wind and solar would be provide the electricity for creating the renewable hydrogen. Then you could locate a bioreactor like this near a CO2 emission site to produce that renewable natural gas using kilowatt hours that would have been completely wasted. So in that sense, they're quote unquote free energy. But there are other implications for this type of work. You can produce ammonia and other products from hydrogen. So part of the attraction of this project for us is the very widespread impact it could have for the entire renewable hydrogen production infrastructure. So if we can really scale this up in the various uses for hydrogen, that would impact a very wide piece of the market. So the final project I'll touch on is pH Matter, and they're using ESIF analytical lab capabilities to develop a lower cost, longer life catalyst material for proton exchange membrane, or PEM, fuel cell systems. So the test capabilities here at ESIF are to evaluate the flow, pressure, temperature, relative humidity, current, and voltage for that system. So here's where I'm leaving you with the important dates on the slide. There's a couple of contact names there if you prefer to reach out to a direct person instead of the userprogram.esif@nrel.gov. So again, our deadline to submit an application is August 30th, and our last day for questions is August 23rd. So we will go ahead and open up for questions now, and we will be posting all of the answers to questions on our FAQ website, on the esif.gov website. So please be aware of that. When you ask a question, the answer is publicly shared. Thank you. Does anybody, I guess we can open it up for questions.
Well, thanks for our panelists. Yeah, we can go ahead and start the Q&A session. If you have a question, please type into the GoToWebinar toolbar under the questions pane. We'll get to as many questions as time allows. I do have one. The first question is, do we need to identify a specific NREL employee to partner with on the proposal?
No, you do not need to identify a specific researcher at NREL up front. Please just describe the scope of work that you would like completed and indicate whether you need someone from NREL to assist your own researchers, or if you would like NREL to perform the project on your behalf. And then we'll go ahead and try to find the right person. And of course, we would confirm the scope and the budget for the project during the negotiation phase. But no, you do not need to identify someone up front.
Okay, great, thank you. Another question that came in, is funding available for the research?
So no, there's no funding available to fund research. What we provide is support for using the facility, and we may also produce publicly available reports, fact sheets, news articles, things like that. But applicants are required to have funding confirmed before they can perform work in ESIF.
Okay, great, thank you. I've got one more. What qualifications do external researchers need to have to do work at the ESIF?
Go ahead. Greg, Joe.
Really, none to start with. It depends on the scope of work that the partnering company, ESIF, needs or wishes to have their personnel do. So there is a spectrum. I guess I'll point to our most common arrangement as an example, and that is we have a partnering researcher come into NREL, and we onboard them and orient them with respect to the site and the campus and physical security, computing security. We orient them also to the spaces that their equipment and or research apparatus would be housed in, so that they have access physically to the space that the equipment's in. Typically, we would have a researcher be an advisor and I guess, operator of computing equipment to support that project. It's kind of a typical arrangement. And if there was any kind of need to enter into hazardous type of work, such as troubleshooting of voltages that are above 50 or 100 volts DC, working on highly pressurized hydrogen tubing systems, mechanically challenging installations and setups. Of course, ESIF personnel are trained, and we have a really competent staff to support doing that. That's not to say that we couldn't allow external people to become trained or to prove their credential and training along those lines and join us shoulder to shoulder in working through hazardous work, but we will hold anyone doing any hazardous work to our safety processes and procedures, qualifications, and approval requirements, which tend to be pretty rigorous.
Okay, great, thank you. Did get a question in about is this applicable for nationals? And
the answer to that is yes. It is It is applicable for foreign nationals and foreign entities. There is an approval process and a sort of background process that DOE goes through before granting access to foreign nationals. But yes, we have lots of foreign nationals working here.
Another question, how do I determine which agreement is best?
So I would start by looking at that link on NREL's technology transfer page. It lists out many different types of agreements. So we can arrange situations where NREL is doing work on your behalf in one type of agreement. We can arrange agreements where NREL is working by your side and you are jointly creating IP. We can, all background IP is protected. We can arrange for you to use the facility independently through either a proprietary or a non-proprietary user agreement. So it really depends on the objectives of your project and the goals, and we will engage our technology transfer officers in the beginning so that we have, so everyone is reviewing the terms of the proper agreement. And that sometimes can take a while, especially if your entity has attorneys and such that want to agree the terms. So if you have an idea of what you want to be doing here, and if you want to get going on the process, I would encourage you to look at the terms and conditions before applying.
I did have a question about having some ideas, and can I share those and get some feedback?
So any question that's submitted through, through this process is shared publicly, but certainly we can comment on some things, but they will be publicly known.
I guess to follow up and respond to that question, we have a pretty good website that we're continually improving for NREL in general. And throughout that website, there's points of contacts for different research centers and personnel who can, field questions and maybe get you in touch with the right researchers or right personnel to kind of discuss ideas. And of course, you can preface that by needing to maintain privacy ahead of that. And I'm sure that we would have folks that, we could get you to the right expertise and then have a conversation about your ideas if that's how you'd like to proceed.
A foreign academic. Foreign American? Foreign academic? I don't know what that is.
Any other questions? Okay, it doesn't look like any more coming in, so we'll go ahead and wrap up the session. As a reminder, you can email any questions you have that come to you later on to the user program email address. You can find more information in the solicitation and online. Thanks very much to our speakers, and we will be posting today's presentation on NREL's Energy Systems Integration Facility website on the Visiting Researchers page. There's a link to the call for user access where you'd find the presentation from today and the recorded webinar. If you have any additional questions, shoot those questions to userprogram.esif@nrel.gov. This concludes today's webinar. Thanks so much for attending. Have a great day.